Hello my friends of Hatari Labs, welcome to this tutorial. This tutorial is kind of very interesting. We are going to cover a very interesting topic that is how to build a massive transient groundwater flow model. That is, for me, my perspective, one of the missing or like not well treated part of groundwater modeling is how to deal with dates, not with times but with dates. I mean, how we can create several time steps based on spread on a spreadsheet. So here we have, you're going to receive the zipped version of this, and here you have the schedule, yeah, for the boundary conditions, yeah. And this schedule for the boundary conditions has values because this is actually based in another model, in another tutorial, so I'm going to leave the as well the tutorial that creates a steady state model. But in this case we want to create a transient model where we are going to cover 93 stress periods, where the first one is steady and the next ones are transient, okay, where for every stress period we are going to have a pumping rate and a river stage and a certain number of time steps, and then as well as a multiplier. And then we can decide based on the table which of these stress periods will be printed. Okay, for example, we want just these 10 days to be printed, okay, and the first day, okay, the steady state we want just to be printed, uh, or even that I'm not interested in having the first one printed, so I'm going to put no, and this here I'm going to put 1.1 and 1.2. Okay, great, so I can save. Mhm. um, and the model will be updated from this table. Okay, so you don't have to do that much. You just have to run all the models, because the with pandas we are going to read this table and we are going to assign the boundary conditions, we are going to assign the pumping rates, the derivative stage based on the table. And let's see and let's explore how is this. Even for well, for me it was an experience to look and have a look about how this can be done, because uh, in my experience when I work with several time steps I usually struggle, well, in model muse, with setting up the schedule for every object, or like when I do it in FlowPy. Actually I just when I do it in FlowPy I use few time steps. Okay, let's see, clear all outputs. Mhm. First, uh, first we are going to inspect the model. So here we are going to inspect the model. So we are going to import FlowPy, and then we load our simulation, and then we want to check if the model is transient or steady. So here we have, okay, in this is the original model, we have 11 time steps, okay, but we are going to change this. And on the period data we have the length of the time step, the number, no, the length of the stress period. Now here we have 11 stress periods, and this is the length of the stress period, this is the number of time steps, and this is the multiplier. Okay, but this and this will be changed later on. And since we don't want to mess around with the original data, okay, we create a copy of that. That is actually here is in model, and then we are going to create model trans, that, and this is created just by changing the sim path. Okay, great. Mhm. Great. So here, this is the we have created this, or if you, well, this let's see. Well, this have created, but I can, since I want that you get the right idea here, I'm going to delete all of this. Okay, and then I'm going to run create and run all cells just to prove that this is created by running all the cells. Okay, so this is created from running all the cells, and then we are going to kernel clear all outputs. Okay, we are going to import FlowPy. We are going to import the simulator, the created simulation. We are going to open the model because there is only one model, and then we are going to open the time schedule, the temporal distribution. Okay, so we have here the date, and then we have here the time steps, and then we see if this is steady or this is transient. Okay, and then we are going to create a time delta. Okay, um, okay. For the first stress period on the steady, actually you have to assign which will be the length of your first stress period. Why? Because uh, whether you can use start and stop, okay. However, this is no much sense because we assume that the length of the first okay, the length of the first transient is the difference from this to this, okay. And on a steady state, actually, it doesn't matter if you are working with doesn't matter the length, in fact, because this is in steady state, okay. So that's why here is just 1 second, okay. And then we got the index, and the index is the difference, okay, in seconds, okay, from this to this. Okay, this is the seconds, but as I remember, you can work with seconds, days, years, and seconds, day, year, and there is another one. uh, and in this case we are working with seconds. Okay, in Modflow can work with four type of unit types and undefined, I guess. Okay, so here we have the length in seconds, but basis on the dates. Okay, so if we here we can, the advantage of this is that uh, we can specify the hours as well. So this is, we might have more control on that. And then here we have time delta. Okay, so here we have time delta. We create a new column that is a time delta. Okay, so this is the length of the stress period. Okay, actually it should be another one that is stress period 0, 1, and so on, because I had to use a counter. You will see that we got the temporal distribution, and this is the period data. Well, this is period data, and there is also that is the ampere, but we got the number of stress periods from the table, so we have 93 stress periods. Okay, what else? So we iterate that, and then we got from the table as well the length, the number of time steps, and the multiplier. Okay, but in this case this is just the first item, but from the table, the ones that are generated from the table. And then we change our TDs, so we assign the ampere to the attribute ampere of TDs, and we assign the stress period data to the attribute TDs dot period data. So TDs will be this. Okay, so we have changed our temporal distribution to this. Okay. Okay, to the 93 stress periods with the corresponding length, number of time steps, and multiplier. Okay, and then we can check that if we write the simulation, so you will see those changes in the TDs. In our case, we are going to wait a little bit. So then we are going to work with the storage package. Okay, so this is actually not going to, well, actually this is not, okay. So where we open the storage package, we get the active key dist, okay. Mm, no, this no. Okay, so we have the steady dig and the transient dig, okay, and then we iterate this. If the mode, okay, if the mode is steady, so it can be steady or transient. If the mode is steady, in the steady dig, okay, in the steady dig it will be true, and on the transient will be false. But if it's not, or in the other case, it will be in the steady will be false and the transient will be true. And that is why it needs these two dictionaries, okay. It need those three dictionaries, because you cannot only type steady state, or you cannot only specify the transient. I don't know why, or maybe I haven't reviewed that much. Okay, so here we can write our simulation, and then we save our river, our new pandas data frame to a new table. Okay, so here what we are going to do is here on model trans, we are going to check here in storage. You are going to see the parameters, and then you are going to see that the first one is steady state and the rest of them are transient. And on the temporal distribution, you are going to see 93 stress periods. This one is steady state and the rest is transient. Okay, great. So then we can go here to part 3, and then we import, we open the simulation. Okay, so what we have done so far is that we have defined the stress period as steady state, and we have defined the stress period as steady states, and uh, no, we have defined the temporal distribution and the storage package. Okay. However, here what we are going to do is that we are going to um, we are going to modify the boundary conditions, because the other boundary conditions were set up for just 11 stress periods, and now we have 93, and for the well and the river these are changing in every stress period. Okay, so here we see model, so we open the geo model. Okay, so we open the time data frame, and then we are going to work with the well package. So in the well package, so there was just from the first no, this is for stress period data. This was for the first stress period, it was pumping, and it assumes that it will be pumping till the end of the model. However, we got the cells IDs, and this is not required, and then we get a dictionary where we assign for every well, because there are 3 wells. Okay, we got the cell ID, because we need that in order to assign the pumping rate. So I say, okay, so this is the index is 0, we have the well stress period data. Okay, and for the iteration we create the wells, this will be in the first layer in this cell, and it will be minus because we are pumping. Okay, so it will be positive if we were injecting. So we have the pumping rate for well 1, well 2, well 3. We create a list of the well, and this list of the well will be for the well is the stress period for this stress period, and then we update the index. Okay, and then we assign to the well stress period data. Okay, so we can see if e is equal to 5, print well, just to show you, this will be the this will be the dictionary, the stress period data of the well package. Okay, and then we are going to work with the river package. So here we got the river package, and well, we got the river data. Okay, so this is the river data for the first stress period. Okay, and we are going to do a copy of that. Why do we do a copy of that? Because in fact this has inheritance. So in by any case, by any how we if by any mean we do assign this to the river package, it will cause a circular reference. So that is why we have to do a copy. And well, we create in this case a river package. So in this case this will be riv spd is equal to riv spd temp rec array if a is equal to 5, print riv spd. Okay, so here we have for the first. Okay, there are many cells. Okay, dear river spd, or well, there are many cells. That is why this is a huge. Let's see, 2. Okay, 1, yeah, 2. Okay, so here these are some previews of the river spd, because the river is set up in many cells. Okay, and then we have to assign this to the river. So this will be riv dot stress period data is equal to riv spd. Okay, here we assign this, and then we call river, and then we have 20, and then here we have river stress period data dot data, and then here we have all that we have assigned. Okay, great. And then we work with the output control, and then this is the data. So we have just the head. It will be printed. The This will be printed the head, the budget for all the time steps in the R type. Will be saving, and this will be in the CBC. Yeah, in the heads, and the budget will be on the heads in the CBC file, and the head will be in HDS file. However, I want to select, yeah, what I want to select is that I want that on the save on the heads, it will be only the ones that I want, and then the ones that I want are just these ones. Okay, I don't want that all of them will be printed, so I just want these ones. Okay, so when the output control is yes, it will be printed. It will be safe. Okay, it will be on the CBC, it will be safe on the CBC, and it will be safe on the heads on the HDS, and as well that will be printed on the LST file. However, this actually it prints all of them, but this save, and I think because I will do another tutorial, I think that this will save on the CBC file. It will save just for this. stress periods. Okay, this is what it was intended. Okay, so we update the save record and the print record. Okay, and then we save our simulation and we run our simulation. Okay, we are going to check because, and this will be, okay, is saving all files and is running, and is running 93 stress periods with a lot of time steps. Okay, and on the, okay, the CBC has the values that the ones that we want, and as well the HDS. However, let's see, let's prove that we are working with a, okay, let's prove that we are working with a with a steady state and then a transient. So in the first stress period, here on the first stress period, this is on the steady state. Okay, so the storage will be 0, and in fact the storage is 0. Okay, and from the second stress period, and this actually printing the last one of the time steps, we have storage coming in, coming out, and then just interesting, we only see storage from the specific yield from the confined parts. Mhm. Specific storage, yeah. Mhm. Yeah, that is interesting. Yeah, because I should see a specific yield. Let's see. Why? Because it might be that here in this, okay, no, in the this v function. Mhm. Mm, storage, okay, maybe here. Oh, okay. Yeah, because all of the files are confined. That is why you don't have this as a specific yield. Okay, we are not going to fix this in this tutorial. Yeah, and well, but you should. Okay, so but it's good that you know that this is, I mean, if you have unconfined and unconfined, you should have sto of sy and sto of ss, sto of ss. Okay, and then here we have till the end. Okay, great. So for the next tutorial, what we are going to do is interactive visualization of the interaction among the river and the wells, maybe with Altair or maybe with Bokeh, and that's it. So we hope that you find this tutorial interesting. We hope that you follow these steps if you are pursuing doing massive transient models updated from spreadsheets. And that's it. So have a great day and thank you for following us.